In this lesson, we're going to have a look at the armature constraint, which happens to be my second favorite constraint. And I'll tell you why when we get there as to why it's not number one. Now, the armature constraint should not be confused with the armature modifier. That is a different thing. This one, we're talking about constraints. But here I've already gone up and done a little bit of a setup here. You can see I've got a top control and a bottom control and a stretchy bone in the middle. Now, I'm going to show you how to use the armature constraint to have this owner bone follow along with our target here, and it will follow along with the twisting and bending of our middle bone here. Now, if you're wondering why this is green, that's because I've already gone ahead and set up a stretch to constraint on this one here, but that's not what I'm going to show you in this lesson. We're going to talk about the armature constraint on this guy here. So to add my constraint, I'm going to select the target, shift select the owner. Now, this is the reason why it's not my favorite. I have selected the owner and the target, and if I choose armature, it actually adds it, but it doesn't add that target bone to it. And that's why this constraint is not my favorite. You still have to manually set things up here. So now that I've said all that, it's time to explain how to add a target here. I'm going to click on this add target bone, and you'll see the bottom has now changed. I can drop this down, and I get a little box here that I can put some information in. I can add more than one target. I can delete it there. We'll add a second target in a moment, but here I want to populate it with the information. So we need the object that it wants to get its information from. So I'm just going to eyedrop our armature there, and then we can choose the bone. And the bone, I've already gone ahead and called it target. So now when we squash and stretch, you notice that the bone follows along. And this is awesome because it also does the twisting. Without this constraint, this was super difficult to set up. But with the armature constraint, super easy, as you saw. All right, so I'm going to show you how to add in a second target. Even though this won't work correctly, I just want to show you how we can add in two different bones, or as many as we like actually. So here I'm just going to target the, let's just target the bottom bone. And it says here that we're weighting our bone at 100% here and 100%. So that technically can't happen. These weights are not normalized. We have this button up here. When we click that, it's actually going to normalize these to give you the true value of them, or our normalized value. So it's going to follow along with our target bone at 50%, and it's going to follow along with our bottom bone at 50%. You notice it being left behind a little bit, and that's because our bottom bone is dragging it backwards. It's kind of like a ball and chain, so to speak. So that's a 50-50 weighting. We can drop this down to 0 if we like, and then normalize again. You'll see this one will go up to 100%. That is our true weights. Or we can do some random value there, normalize weights. There we go. We've got 0.834951 on that one, and then we've got 0.16504 on that one. And the beautiful thing about these weights is you can actually animate them with this button here, or you can set a driver, which is something that we do with parent switching. You can use this constraint to switch parents. This would be the first parent, and this would be the second parent. And you can have as many parents as you like, just like the real world. So now with these last three options up here that I haven't explained, the use envelopes and the use current location, to be honest, I actually don't know what they do. I know it's got something to do with envelope weights rather than using vertex group weights. And they are related to each other according to the documentation, although it's not quite clear from the documentation. I've tried to make sense of this, but future me will probably figure out how this works. But thankfully, I haven't actually had to use these options. But the other setting, I do know how this works. When we choose preserve volume, this is exactly the same as preserve volume when we use our armature modifier. And that will give you more accurate volume preservation, especially when dealing with any rotation like this twisting here, or just any straight rotation of a bone actually. So sometimes you need this on and sometimes you don't. And that's exactly like the preserve volume option in our armature modifier. Now, also like many of our other constraints, we need to be careful of double transformations on this one. So I've set this up and the owner bone does not have a parent. We can go over here into our relations tab and see that there is no bone in here. However, if we did have a parent here, let's just choose our bottom to be our parent, keep offset. It might look okay when we move this one. It looks like it's working correctly. However, when we move the parent, you'll notice that it's moving up and going crazy. And we've already learned, and that is because it's getting double transformations. One lot of transformations from our armature constraint, and then one lot of transformations from our parenting. All right, and that is it. That is our armature constraint. It is my second favorite, but it's awesome. Give it a go.